Well, yeah, I mean, it's really a pleasure for me to be allowed to share some of my ideas here on this subject. So I will jump right into it. Is the sampling method as valid as the analytical method? Well, we are talking here about trends and challenges in analytical chemistry. And in this particular case, I will try to highlight some of these trends and challenges in relation to sampling and dealing with samples. Well, it certainly is a challenge. I think everybody is aware of that. It has been for years. So maybe it's not a trend as for the challenge. I mean, it has been there for all time, dealing with the sampling preceding the testing in the laboratory. The trend, however, might be that this has become more and more in focus, and not least in the latest version of the 7025 standard. And we will look into some of that. Well, Eurachem has been dealing with this also for quite some years now. In 2007, we issued Eurachem issued the guidance on dealing with measurement uncertainty arising from sampling. And a second edition was issued a couple of years ago. And we are also touching on it, but not enough, in the guidance on fitness for purpose, the guidance on method validation, which Vicky also just referred to. And we are, as you also mentioned, currently working on a third version of that. And that's where we will look into one of these related topics, exactly the sampling and sample handling. So we are actually adding a new subsection to the new version of the guide, where we'll be coming up with some ideas on sampling and sample handling. And that's the ideas I want to share with you today. Please note that what we're going to give in this subsection on the guide on validation is not a comprehensive guideline on how to validate sampling procedures, but we will come with some ideas here later. I should also mention that this is something under development right now, so don't take any of my statements here as a formal Eurachem position on the subject. This is still something we are working on and discussing. So, well, method validation, we talk about the situation where a client needs something to be tested by a laboratory, and we want to apply a method for the purpose. And we want to be sure that this method is fit for the purpose. And that's why we are talking about method validation. And this can be defined in many ways. Here, the process of proving that an analytical method is acceptable for its intended purpose and gives results which are valid for decision making. So the client can be happy, well, he gets results which he can use in his decision making. The problem or the issue, the case is mostly though that we are focusing on the analytical process in the laboratory. We are talking about all these steps going on in a typical laboratory. It can be a long, complex process. It can be a short process. There can be many kind of operations involved in that process. But we are aware that whatever kind of process, and especially the long, complex one, there might be a number of critical points to be aware of when we validate our method, where things can go wrong. And that's also why I want to highlight here that one of the purposes of method validation is also, and not least verification, is for the laboratory to be aware of these critical points and be careful in the routine performance of the method, where to handle the method very cautiously. So, but we are looking inside the four walls of the laboratory. But there is something here, just inside the laboratory door. Somebody every now and then comes and places a sample to be tested. And where does it come from? And what's the condition of it? That's what we're going to look into. So something is happening outside the laboratory door, which is also important for the validity of the final result of the whole testing. And that's, of course, the sampling. That's the sampling where we can also identify a number of critical points from the condition of the starting materials and the conditions during the sampling procedures taking place, the whole sampling procedure, how is that performed? How do we contain the samples? How do we transport them from the sampling spot to the laboratory? So in addition to what's inside the four walls of the laboratory, there are a number of issues also here to take care of, which will influence the validity, we will come back to that, of this sample here to be tested. Is it fit for testing? And it's fit for giving fit results by then, because we're going to issue a report with some results here. And the question is whether that actually says something reasonable about that starting material out there. So that's the challenge here. And as I said before, it's not a new challenge, but what maybe is a bit new what I want to share with you today is that, is this really only something taking place in the laboratory, and what can we do within the laboratory to kind of be in control of this situation out here? Well, I came across this old, and many of you may have seen this before, this old Horvitz figure defining what different types of samples, talking about sampling operations on one side, analytical operations on the other side. And over here, no sampling error. So, I mean, these were two split processes. Anyway, I'll not dwell with this one, but go on and look at what are we talking about when we are talking about valid methods versus valid test results? Well, yeah, the valid methods are expected to give valid results, and by valid results, I mean results which are fit for making decisions, whatever kind of decisions is going to be made by the client. That's what we're ensuring through validation and verification in the laboratory. And yes, as I said, meaning that this is fit for the purpose of make reliable results. But this is not only depending on the validity of the test method, but also, and I would actually say, if not in most, at least in many, many cases, the validity of the sampling and sample handling is equally important. So uncertainty from sampling, as we probably know, or at least have the feeling of that this is probably often much bigger than the uncertainty contributions coming from the analytical procedure itself. So we have been very keen for many years on dealing with measurement uncertainty and measurement uncertainty budgets and all that kind of stuff within the four walls of the laboratory. But coming to the final result and the uncertainty of the final result, the contributions from the sampling part taking place outside the laboratory may be just overshadowing the uncertainties from the laboratory. And this is exactly what's now been more and more in focus in the new version of the standard. It's mentioned specifically that we should also take into account the uncertainty contributions stemming from the sampling processes. And I would like to also highlight another quote from the new version of the standard. But it's actually only in a note. Validation can include procedures for sampling, handling, and transportation of test and calibration items. It's only a note, it's not a requirement, and it even says can include. So when should we do that? I mean, the standard is not very strict on this, and maybe that's a trend that it's now in there. Maybe in the next version of the standard, it says you must include. But I think also that those making up the standards are aware that we certainly have some challenges here in doing that. So we are taking some steps out in new land here, more or less, talking about validation of the procedure taking place outside the laboratory door. So talk about a valid sampling procedure. Well, we have talked about the contribution to the measurement uncertainty on the final result, but I would like to expand that. I'm not sure we can only talk about measurement uncertainty when we talk about the validity of the sampling procedure. We must also secure it fit for the purpose of giving us representative samples. And we know there are a lot of things which can influence the representativeness of the samples being brought to a laboratory, in homogeneity, conditions at the sampling spot, different times for the sampling, the devices we use for the sample, the skills and experience of those performing the sample. All these factors will influence how we can secure that these samples brought to the laboratory are valid. And by valid, I mean fit for testing. Is it worthwhile testing them at all, or do we know that this is not really representing the starting material anyway? Then we could stop at the laboratories and say, well, there's no reason for testing this because this is not a valid sample. And we see now all these risks here. We have been talking about risk assessments. Certainly there are a lot of risks here. We must somehow at least be aware of some critical points, some risks here, which we must be aware of and try to handle and control and monitor and possibly quantify and evaluate as good as possible. The problem is, and that's a kind of paradox to me. I mean, maybe somebody can enlighten me, but I think we have a paradox here that to evaluate the validity of the sample, whether it's good enough, whether it's representative of the starting material, well, that can only be seen after we have tested the sample. It cannot be seen at the laboratory door, not until we have been testing it and got a result from it. And well, maybe then it's too late. I mean, at least we have lost some time and resources on testing something which was not worthwhile testing anyway. Digging into the things of valid test results versus valid samples, I would like, again, to take something from the new standard, where it actually, in relation to reporting, requires that a report should contain reference to the sampling plan and sampling method used by the laboratory or other bodies, where these are relevant to the validity of application of the results of the testing, right? Coming after have testing the samples being brought to the laboratory door. Where these are relevant. I mean, I was thinking, are there any cases where it's not relevant if some sampling has been taking place before the sample was brought to the laboratory door? I couldn't think of that. So it's a very important statement here. Well, then we may be saved by the bell. So, well, maybe somebody has predicted or required a mandatory plan to follow, a regulation or a standard method, whatever, which we must follow. We touched briefly on that yesterday. Maybe that was in our breakout group, I cannot remember. But anyway, that there are some fixed methods which must be followed. I know specifically in the food area, there are some EU regulations in the field, and there are also something in the environmental area. So we just have to follow these required processes for sampling. The question is whether these procedures are valid and provide valid samples for testing. We don't know. Who are these people who make these plans? Have they based them on real scientific studies, or it's just a kind of more or less political statement that, well, we better do so and so and so. So what can we do now? Yeah, well, what can be done to ensure or improve the validity of sampling procedures and the samples, and who is responsible for doing that? Well, this little mark here is not to remind you these COVID time that you should every now and then go and wash your hands and disinfect your hands. It's actually It's actually a little saying we have here in Denmark, and when we have a situation where some people, a bit of tricky and fishy situation, and nobody wants really to take responsibility for the outcome of that situation. So we say, well, there will be a queue of people in front of the sink washing their hands, not taking responsibility. And I think this situation is a little bit where there will be a queue around the sink washing hands, because who are responsible for this? Those who made these regulations, those taking the samples, the laboratory not evaluating the value of this, the quality of the samples good enough. Well, everybody wants not really to take responsibility on that. You say, well, this is not my problem. We have 3 scenarios. At least I try to split it up in these 3 scenarios. The laboratory is not responsible for the sampling processes. The samples are simply brought to the laboratory door and we test it as it comes, and that's where we have this well-known and important statement in the standard that a report should include a statement to the effect that the results relate only to the items tested. We're washing our hands. We don't know what's going on outside the laboratory door. We just tested this, and this is the result of this sample. There are the other situations where the laboratory, for some reason, are responsible for the sampling, either as a natural part of the method the analytical method they are performing. They are reaching out and say, well, we better also go out and take the samples. Or they have the offer that service to their client that we can also do the sampling or whatever. So this primary sampling out there in the field is done by the laboratory itself. And then there's a particular specific situation which is probably mostly well known in the environmental field, well, also in some food areas, but where we are moving the whole test situation out into the field and bringing the test equipment out there, maybe doing a few sample preparations out there on the spot, or measuring directly by the kind of device developed for the purpose. We talk about in situ measurements when we are just sticking some kind of sensor into the material and get a response which we can convert to a result. Or we do the sampling quickly there, and then we have the device out there in the field, and we do the testing in the field instead of having to transport the sample all the way back to the laboratory. So we can talk about at-site testing. We will look a little bit into these 3 different scenarios. Well, when the laboratory is not responsible for the sampling, of course, the direct validation of the sampling procedure is not possible seen from the laboratory side of view. That's what I'm talking about here. What can we do from the laboratory side of view? So maybe we could do some verification of the validity of the samples being brought to the laboratory. We know that's already a requirement in the standard, how to receive and handle samples in the laboratory. And I will come back to that a little bit later in another slide. In that context, we have not been talking about validity of the samples, but more maybe quality of the samples. But to me, it's more or less the same. But maybe the laboratory can do something also in this situation, reaching outside the laboratory door and getting contact with the sampler, whether that's the client himself or he has hired some who are professional in sampling and specifically experienced in taking samples. And we could reach out and make them aware the importance of the sampling process. Make them aware that if they are not careful, this may influence the validity of the sample brought to the laboratory, and maybe it's not suitable for testing at all. So at least we could do that. So they take care when they are doing the samplings and containing the samples and bringing the samples to the laboratory. So this kind of communication with the client sample, whoever it is, we should highlight some critical points in the sampling process and in the transportation process, also important. maybe reach out by preparing sample containers. I worked in a laboratory many years ago where we actually did that. We prepared the flasks, and we marked the flasks, and we cleaned them, and they were packed in nice boxes, and they were just picked up by the client, who then brought them to the sampling spot and filled in what was filled in there, and brought them back to the laboratory. So we could somehow take care of part of that process. And we may also, even based on our experience in talk about validation, we may even recommend them to try to do some validation of the process they are responsible for out there. Second scenario, validation, the laboratory is responsible for the sampling. Well, of course, then we are in the whole process is in our hands, and either we should validate it if we are building it up from scratch, or we should verify a standard method used for that purpose. And it can be conveniently combined with the validation of the measurement process, the testing process in the laboratory. And that gives us the opportunity to overcome this paradox of not being able to evaluate the quality of the sample, the validity of the sample at the laboratory door, because we are doing that ourselves as a part of the entire process. Field testing, I will not say a lot about this, but certainly there's a very big, good reason for thinking in validation and verification terms in relation to that, because that's really something going on under special conditions there, which may impact the result of what is taking place out there. And one way of doing it is, of course, to compare with in-house methods, so we can see if we get the same results for the field method and the in-house method. Sometimes it's very much based on some kind of device produced by some smart producer or manufacturer who has come up with a smart device praised for being able to do everything. But again, we should verify that this documentation about this kind of equipment is trustable. And maybe we are here more talking about the instrument qualification. I promise to come a little bit back to this requirement in the standard on how to handle samples at the laboratory door, at the receipt of the samples. And that's where we, in these terms, should evaluate the validity of the samples, whether they are fit for actually doing the testing on them. And well, we know that there are a lot of things we can look at: immediate appearance, how the sample looks, how the packaging look, how it was transported to the lab, it was kept in cold chains or whatever is relevant and necessary. But anyway, I mean, if the sampling process leading to a sample being brought to a laboratory was not a valid process, we cannot change it. So it always depends on the validity of the sampling process. Just to come to some conclusions. I mean, as I said in the very beginning of this is just some ideas. We still have to work on this, to elaborate on this. To quote a little bit from the measurement uncertainty from sampling guide, it's more seen here that the validation of sampling procedure can be seen as an estimation of the uncertainty as the primary purpose of doing the validation, meaning that it's the method is valid if the uncertainty stemming from sampling enables the final measurement to be fit for its intended purpose. I mean, the uncertainty from the sampling plus any uncertainty from the measurement process, those combined will still be acceptable. As I said before, I would like to see other aspects of validation also, but of course, on measurement uncertainties is a very important point here. Another statement I would like to make here by end is that in-house handling of preparation of samples should be validated, verified, of course, together with the testing method. But the validation or verification of the primary sampling taking place out there in the field is where we still need some good guidance, and that's what we are trying to work on. So what can we do? It was already mentioned. I cannot remember who mentioned it. I think it was Kyriakos, that there are more and more PT schemes involving also the sampling processes and even combining the sampling process with the testing processes. So that's a good tool, but I mean, that will certainly not cover all sectors, all fields as of now. Well, maybe we should just close our eyes, follow the procedures standard method given to us. I already raised the questions about those. But I will also mention that we are working on this in Eurachem. I mean, this is in cooperation with the working group on uncertainty from sampling. The method validation working group has now started a cooperation on this issue. We will actually have our first talk about this here in June, where I will attend the meeting in the uncertainty sampling from sampling group, and we will see if we can get a plan for how to come up with something here. And so maybe we have something interesting to tell you in a year from now, if we have developed something which could be useful in this area. So this situation we saw before, but it has changed. Now it's this whole situation we must look at, ensuring that the entire testing process is acceptable for its intended purpose and gives results which are valid for decision making. So we are aiming at that.